In this video, let's talk about the equations for momentum in physics and conservation of momentum. Let's first talk about the general momentum equation first. We use the letter P with the arrow, right, to represent momentum. It's a vector, and that's equal to mass times velocity. And velocity is also a vector, so there's an arrow here too. That's the general momentum formula. Okay, now to talk about conservation of momentum, we have to first talk about Newton's third law of motion, action-reaction. Now, let's say there are two objects collide with each other. So let's say there are two balls collide with each other. Let's say that's ball 1 and that's ball 2. And ball 1 is moving this way. And ball 2 is moving this way. And they collide with each other. Now, the force acting on ball 1 is the force of ball 2 acting on ball 1. So we can write that, right? That's the force of 2 on 1. And the force acting on ball 2 is the force of ball 1 acting on ball 2. So we can write that as force of 1 on 2. And these two forces should be equal in magnitude, but opposite in direction. So I put the negative sign here. Okay, now, if I move everything to the left side, I have this force of 2 on 1 plus force of 1 on 2 is equal to 0. Now, the net force on the system is 0. The momentum of the system is conserved. Now, to derive the equation for conservation of momentum, right? We have to come back to this one here. Here, force of 2 on 1 is equal to negative force of 1 on 2. Now, what is the equation for force? It is mass times acceleration, but we're talking about object 1 here, right? So mass of 1 and a sub 1 is equal to negative m sub 2 times a sub 2. Okay, now, we also know that acceleration is just change in velocity over change in time. So that is m sub 1 times change in velocity of 1, object 1, right? Over change in time, 1 is equal to mass of 2 times velocity, change in velocity of 2 over change in time of 2. Now, the time of force of ball 1 acting on ball 2 is the same as the force of ball 2 acting on ball 1. So change of time 1 is equal to change of time 2. We can say that. Then this and this cancel out. What we have left is m sub 1 times change in velocity 1 equals to negative m2 times change in velocity 2. Okay, now, what is change in velocity? It's this. V final minus V initial of object 1 is equal to negative m sub 2 times V final of 2 minus V initial of 2. Now, distribute the m. We have m1 V final 1 minus m1 V initial 1 equals to negative m2 V final 2, and that will become plus m2 V initial 2. Now, we want to rearrange the equation so that all the signs are positive, right? So I can move this one to the left side and move this one to the right side. But normally, we want to write initial equals to final, right? So we will write in this order. So m1 V initial 1 plus m2 V initial 2 is equal to m1 V final 1 plus m2 V final 2. And of course, right, if you want to use V as V initial and v prime as v final, you can rewrite this into this. That is m1 v1 plus m2 v2 is equal to m1 v prime 1 plus m2 v prime 2. Okay. Now, this equation here can be applied on both inelastic collision and elastic collision. However, we do have to know that in an inelastic collision, the total kinetic energy after the collision is different from the total kinetic energy before the collision. But in an elastic collision, the total kinetic energy after the collision is the same as the total kinetic energy before the collision. Because of this, we have another equation for elastic collision, which is what I'm going to talk about right now. So here, force of 2 on 1 is equal to negative force of 1 on 2. Okay, as we know, the general equation for force is for this one. So force of 2 on 1 is equal to mass 1 times acceleration 1, right? And for this one, negative force of 1 on 2 is equal to mass 2 times acceleration 2. Now, let's talk about this one first, okay? So we start with this one. Force of 2 on 1 is equal to mass 1 times acceleration 1. And we know that acceleration 1 is change in velocity over change in time, right? So that is equal to mass 1 times change in velocity 1 over change in time 1, which is what we just did, right? Okay, we have to write this in calculus this time. So that is equal to mass 1 times dv1 over dt1. Now we can apply the chain rule on this. That is dv1 over ds1 times ds1 over dt1, right? As you can see here, ds and ds cancel, we have dv over dt, right? Same as this. But we know that ds1 over dt1, so ds over dt is velocity. So we can write this as mass 1 times velocity 1 times this dv1 over ds1. Now, multiply both sides by ds. We have force 2 on 1 times ds1 is equal to mass 1 times v1 times dv1. Okay, of course, we have to integrate both sides, right? So since we're integrating ds here, we will evaluate from initial position to final position, okay? So that is force 2 on 1 ds1. That's equal to, of course, right? Integrate this side. We're integrating dv here, so it's from initial position to final position. Mass 1 times v1 times dv1. Okay, to integrate this, we will just times s, right? So that is s, evaluate from initial position to final position. And that is equal to add 1 to the power divided by the new power. We have half m1v1 square, right? Evaluate from here, initial velocity to final velocity. Okay, now here, so this one will become force of 2 on 1 times final position 1 minus initial position 1 is equal to here, half m1 times final velocity 1 minus initial velocity 1. Now this is change in position. We can rewrite this as times delta S. And that's equal to, let's distribute this, half. Oh, that's a square here. Okay, so here, right? Because there's a square here. Okay, so this is m1 v final 1 square minus half m1 v initial 1 square. Okay, now next we will talk about this one here, and we will do exactly the same thing. Negative force of 1 on 2 is equal to negative m2 acceleration 2, right? And of course, acceleration is changing velocity over time, right? So that would be this, change in velocity 2 over change in time 2. And then we have to write this in calculus, right? So we will have this times dv2 over dt2. Apply the chain rule again. We have this dv2 over ds2 times ds2 over dt2. Right? The twos are subscripts. Okay, now ds2 and ds2 cancel out. We still have only dv over dt left, which is the same as this. Now we know that ds over dt is velocity, change in position over change in time, right? So we can rewrite this as negative m2 times v2 times dv2 over ds2. Multiply both sides by ds2, we have this times ds2 is equal to negative m2 v2 times dv2. Now, of course, integrate both sides, right? But we can move the negative sign out of the integral sign. So let's do this, right? We're integrating ds here, so from initial position to final position. And move the negative sign of the integral sign, we have this as well, right? Since we're integrating dv here, so that is initial velocity to final velocity, right? Here. Now, this is this, right? Negative 1, force of 1 on 2 times s, right? Evaluate from initial position to final position is equal to negative here 1 over mass of 2 times velocity 2 square. Evaluate from initial velocity to final velocity. Okay. Now, that would be this, right? Times initial. Okay, so that's S2, right? S sub of 2 because of the second object, right? Final position of object 2 minus initial position of object 2. And that's equal to negative 1/2 mass 2 times v final 2 square minus v initial 2 square. Now, this one here is just change in position, right? In the bracket. So that is delta S2, right? Is equal to here. Let's distribute this. We have negative 1 over 2 mass 2 times final velocity 2 square plus, right? Half mass 2 times initial velocity 2 square. Okay, now we can come back to this one here. Let's do here. Since force of 2 on 1 is equal to negative force of 1 on 2. Of course, if you integrate both sides, they should equal to each other as well, right? So what's the integral of this? It's this one here. So we can write this as here half m1 v final 1 square minus half m1 v initial 1 square. And that's equal to what's the integral of this? And that's this. This one here. Minus half mass 2 v final 2 square plus half m2 v initial 2 square. Okay, now let's rearrange the equation to make every term positive, so I can move this one to the left side and this one to the right side, right? But again, we want to write something initial equal to something final, so we will write this instead. So that would be half m1 v initial 1 square plus half m2 v initial 2 square is equal to half m1 v final 1 square plus half m2 v final 2 square. Again, if you want to write v initial as v and v final as v prime, okay, you can rewrite this as half m1 v1 square plus half m2 v2 square equals to half m1 v prime 1 square plus half m2 v prime 2 square, right? Okay, that's the second equation. But this only applies to elastic collision. Okay, now let's do a summary here. In an inelastic collision. Now let's say complete inelastic collision, okay? So complete inelastic collision. Okay, so you can use this formula, right? m1 v1 plus m2 v2 is equal to m1 v prime 1 plus m2 v prime 2, right? Now, when it is completely inelastic collision, after the collision, both objects will move together, right? So in that case, right, v prime 1 is equal to v prime 2, and we can just call that v prime, okay? Since both objects will stick together and move together in one direction, right? So now, what does that mean? That means this, right? m1 v1 plus m2 v2 is equal to m1 v prime plus m2 v prime, right? Because v prime 1 equals v prime 2 equals to v prime, okay? But since these v primes are the same, we can rewrite this, right? m1 v1 plus m2 v2 is equal to m1 plus m2 times v prime. Now, if you want to find out the final velocity of the two objects who's moving together, right? So to find v prime, just rearrange the equation, right? And that's equal to, now v prime is equal to m1 v1 plus m2 v2 divided by m1 plus m2. Okay, so that's inelastic collision, complete inelastic collision. Now let's talk about elastic collision. Okay, you have two formulas to use, which is the first one as well, right? And the second one, which is the kinetic energy formula, right? So there are two equations for the elastic collision. And of course, right, in an elastic collision, V final 1 and V final 2 are not the same. So that's why you cannot solve it like this, right? So, but assuming that they are normally not the same velocity, right? So you have two equations here. If you want to find out the final velocity of the object 1 and object 2, which is v prime 1 and v prime 2, you have to solve system of equations, okay? Because you have two equations here, right? Okay, now to find v prime 1 and v prime 2, you have to solve system of equation. Okay. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.